This is a new display that we're developing that uh, will be present in the future in NeuroGuide. It's being developed primarily by Ernesto Soler. It will be initially implemented in our Evoke Potential program, and then also we will be using it in NeuroGuide as well. This is a preliminary display in which you can see there are sagittal, horizontal, and coronal images here. And there's also rendered heads. We have these rendered surfaces already in the evoked potential. We now are going to calculate inverse solutions and show the projections of the sources of evoked potentials onto the cortical surface. Going to quickly just go through some of the features that you'll see in the future. These are now OpenGL that will be written and imported into NeuroGuide. These are different options. For example, we can go to an atlas and evaluate both the maximum points of energy. Up here you see contours. This, for example, is the contour of the Brodmann areas, all the Brodmann areas in the Montreal Neurological Atlas. And we can select which Brodmann area has which maximum value. And so those are contours. We can also fill those contours. We'll show in a minute. We can take movies of the changes in contour, the values in the contours, for example, z-scores or the currents, at different points in time for the time domain LORETA, and we use also what's called swLORETA. That is a weighted standardized LORETA that Ernesto has developed. Now those are all contours you can see of the Brodmann areas at different views. Contours, there's little red lines around there. Now we can go down and we can look at different aspects of the atlases. There's different atlases, but the main atlas we'll be using will be the neurological one from Montreal Neurological Institute. There's a toolbar that allows you to easily do things. You can select or deselect different Brodmann areas. In this case, we deselected some, but we can also now fill them in and just create them. In this case, we've selected all, and we're going to fill the Brodmann areas. This is not the best way to do things, but you can select particular Brodmann areas, fill them in, and then you'll be able to select the z-score threshold that you want to look at for one or more, all 88 Brodmann areas you can look at. And that gives you great flexibility. Again, this is the view menu that allows you to add grids to do a number of different things. You can have different kinds of maps. In this case, we're going to be looking at a 3D view that you can look around. Now here, that last view was the all slices view that you see in LORETA, the Standard Key Institute LORETA. These are using the equations of what's called, as I mentioned, weighted standardized LORETA, swLORETA, but with 7mm slices beginning from the bottom of the head. And here we go with all the slices. On the upper left is the bottom of the brain, and all the way to the end here is the top. The outlines are Brodmann areas as you go from the bottom of the brain up to the top of the brain, and with the outlines of the Brodmann areas. There's over 4,000 voxels in this view. It's over twice the number of voxels that are in the Key Institute LORETA. This case is an swLORETA solution mathematically, but it's weighted by virtue of weighting towards the sources that are deeper get higher weightings. So there's a lot of different ways to look at these inverse solutions. You can color them in a different way. In this case, you can get the outlines or different colors and contours, which you can changing around with different colors, and with colors and also magnitude of the z-scores themselves. And we can also look at the maximum intensity of z-scores, or the maximum value of z-scores in different planes. For example, we can change transparency of the view. What we're doing here is changing the transparency so that you can look at different Brahman areas in different ways. Now we will simplify these a lot of these options so you don't have too many of them. They can be rather overwhelming, but the idea here is to show you a new view. Now this is an example that I was mentioning, the three planes. This is looking at the maximum voxel from the top down. This is a coronal slice, and this is a sagittal slice. And you're looking as though there is a transparent brain. You're looking down inside the brain, through the skull into the brain. And here you can see a very large value in the temporal lobes that are over here, but you can't see it as well. You got to go over to the sagittal view. The coronal view will give you a different view of the maximum voxels. This scale you can adjust for z-scores, so you can move it up and down. You look where the maximum z-scores are. You can set the threshold so that you're only looking at 2 standard deviations or 1.64 standard deviations or whatever you want, 3 standard deviations, as you try to link patient symptoms to the most deviant Brahman areas and nodes of networks that are linked to the symptoms. As I mentioned, we can do a time course with this, a time series, and a lot of other things. And so this is really just a preliminary view of what will be available in the future. Will be available inside of NeuroGuide and also inside the ERP module of NeuroGuide. In the future, it'll come out first in the Evoke Potential module and then later in NeuroGuide itself. So I wanted to show this to you so you can get a view of the future of inverse solutions as we begin to develop these new tools.